Hello, hello. Welcome to the Modeling 1 lecture. Hope you guys had a wonderful 3-day weekend. Without further ado, let's get started. Okay, so for some brief announcements before we begin, let's talk about office hours. So starting now until essentially the end of the semester, we'll be having office hours every Monday and Friday from 5 to 7 p.m. at SOTA 3:30, and also on Discord. So if you cannot make it in person, no worries. We'll also be on Discord if you need any help with like homework, or you're talking about your project, or you just want to chill and hang out with us. Feel free to pop on by. Okay, so this will be our agenda for today. First, we're going to be talking about the components of a mesh. Then we're going to be talking about some best practices on how to model effectively. Then we're going to be talking about some modeling techniques in which I'll demonstrate that in the demo. Please pay attention. There is quite a lot to cover, and these are very, very important to keep in mind. Though if you want, you can play this at 2x speed. That's okay too, as long as you get all the information in there. Okay, so firstly, let's talk about meshes. So a mesh is comprised of a bunch of faces, which are comprised of a bunch of edges, which are comprised of a bunch of vertices. Think of it as just each of them are a components of each other. So you have this vertice here, and if you have two vertices, then they form an edge. And if you have more edges, then you form a face, and then a bunch of faces together form a mesh. So like this human head over here, this is a mesh. So meshes basically refer to the whole geometry that you're working with. That's a mesh. So they compose of these vertice positions that define the points in the mesh, and then the computer does some magic, and then you get some really cool 3D model, essentially. Topology is the concept of these connections or these edges that flow across the different faces of the mesh, and we'll be talking about that a bit more later. Meshes aren't actually the only representation of 3D geometry, though. They are the most common representation. They use a lot in like animation, in video games especially. But there are also like other representations of a mesh if you're more interested in like the theory behind that, such as NURBS, point clouds, voxels, etc. If you're interested in how you can like represent a 3D geometry, I encourage you to definitely look that up outside. But for the purposes of this class, we'll mainly be dealing with meshes. Specifically regarding meshes, we want something called quad meshes, which are four-sided faces. And the reason for this is it allows for better edge flow and for smoothing and for animation purposes, and which we'll get into later. And we want to avoid things called floating vertices and n-gons. So what are all these like all this terminology that I just threw at you? So this is what an n-gon is. So n-gons are faces with more than four sides. So you see in this image here, you have this quad, this square here, right? A quad, quadrilateral, has four edges, right? This is a tri, so like a triangle. These are generally okay and what you want. Tris are kind of iffy, but they're okay if you have to. But you generally want quads. What you don't want are these n-gons. N-gons are any faces with more than four sides. So you can see how this one has one, two, three, four, and five sides. And this one has one, two, three, four, five sides. These are really, really bad because they cause really weird shading artifacts. And when you end up animating and deforming them using rigging and that type of thing, they have a lot of weird deformations and cause unintended consequences. So really try to avoid n-gons as much as possible. Try to keep them all as quads. Next, let's talk about edge flow. So the edge flow is basically how a model's edges move across the 3D surface. So it's really important for the shape of it, but also especially when you get into animating and rigging and skinning and all that type of thing. Good edge flow basically determines how well your model can sort of deform and move and animate properly. So essentially, the core tenets should be that they should form a continuous path across the entire model. So you see how in this example of good edge flow, these edges sort of like go across the entire width of like their shoulder, right? Like this head here, they go all the way around and they loop back around. This is called an edge loop. And they should also be relatively organized, right? So, for example, if you look at the example of bad edge flow over here, they're kind of like all over the place. It looks kind of ugly and disgusting. Like there's a bunch of like triangles everywhere, and then there's like it's flowing all over the place, and there's like crisscrossing and all that type of stuff. That's pretty bad, right? You want the edges to sort of be relatively organized and sort of smooth, like in the good picture over here. Next, let's talk about manifold geometry. So these are some examples of non-manifold geometry. So if you have three faces that share a single edge, that's bad. If you have two or more faces that share a vertex but not an edge, that's also really bad. And then adjacent faces have opposite normals. You don't have to worry about this too much because we're not going to get into normals too in depth. But here are some other examples of non-manifold geometry. So anything that has a hole in it, um, like this right here, you have three faces that share an edge. Over here, internal faces. So like, let's say you have an enclosed cube, but there's actually like a face inside of it. That's non-manifold, and that's really bad. It causes a lot of issues. Things like surfaces being connected with only one vertex, that type of thing. So very, very important when you're modeling. Try to keep your geometry manifold. It will save you so many headaches in the future. Don't have any open holes. Try to keep your edges not having like these weird three faces that connect to a single edge, that type of thing. Especially also internal faces, don't have any internal faces. This can be quite a common error to just like accidentally come across. And when you're like sort of debugging why your mesh isn't like working as intended, this could be one of the main issues that could happen. Yeah, so how do you troubleshoot non-manifold geometry? One thing you can do is to view your mesh in smooth mode, which we'll get into a bit later. Um, Additionally, if you see a surface that isn't like smoothly shaded, that can be indicative of non-manifold geometry. If you have any faces or edge loops that don't like follow the rest of the mesh. And if you want to fix it, just delete the problem area and just try like rebuilding those faces. Just like delete it and then just try remaking it. And that should generally fix the issue. So here are some examples of that. So smooth mode basically like smooths everything out. And you can see here how like these edges should like loop around, but there's this like weird like hole thing in the middle. This particular issue is an example of you extruded the face, but you didn't move it. And that causes this issue here. And if you can look here, you can see how like the shading of it, like the colors of it are all off and like janky, especially in this location. This is indicative of some type of non-manifold geometry that's being applied here. Next, let's talk about topology. So topology consists of a couple core tenets that you really want to keep in mind. Essentially, it's just the combination of everything that we talked about before, right? It means having good edge flow, not using more faces than needed to uniquely define a shape. So, for example, if I have a cube, I don't need to have a million vertices and a million faces to sort of define that cube because a cube is a very simple object. I don't need to have an excess amount of faces to define it. Additionally, have similarly sized quad faces. I don't want certain faces to be really, really big and other faces to be really, really small. Generally, you want to keep them around the same size. Additionally, you want to minimize or get rid of as many n-gons as possible. And the reason you want to have good topology is because it makes it a lot easier when you're rigging and you're animating and you're trying to make your 3D model sort of move and deform as well. Also, yeah, manifold geometry. Make sure you have manifold geometry in like to have good topology. So here are some examples of bad topology taken from r/topology gore on Reddit. You can see how on this left example, there's a bunch of tries. There's these like weird like edges that sort of like crisscross into each other and they're like overlapping and it generally looks pretty disgusting here. I mean, some of the stuff isn't bad here with like the chin area, but then you get to like this area around the eye and you can even see the shading artifacts that are happening over here as a result of this really janky topology that's happening. Here's another example of really bad topology. You can see just like an over excess amount of edges, and then here like the faces sort of like intersecting with each other really weirdly. These tend to happen a lot if you're taking like photogrammetry scans of like real life objects and converting them into 3D. You tend to have this, and you gotta fix it up, and it's pretty annoying. This is also a bad example of topology where like you don't have as many tries. Like there's maybe like one try here. There's like virtually no n-gons, but essentially there's no edge flow. It's not flowing smoothly. These are all kind of just like going all over the place. The like especially the faces. The faces aren't like the same size. Like this face right here is massive, while like these faces are a lot smaller. And these are examples of bad topology. So this is a good example of topology where I have this really, really high detailed car. All of the edges sort of like loop in and forward like a giant edge loop. Everything looks super clean. All the faces are relatively the same size. There's no janky n-gons or anything. They're all quads. This is a really good example of topology for sort of hard surface objects. And then you have this face model here. This is a really good topology here. You have sort of even faces. You have these edge loops that go all around the face and everything. And essentially, just bad, good, bad, good. Yeah. So try to get good topology as much as possible. It's definitely a skill, and there's a lot more theory that goes into like what topology makes it good and that type of thing, especially when you're making like faces. But we won't get into that right now. But essentially, just keep this in mind when you're modeling your props or your assets. Okay, let's talk about some modeling techniques. So here's a review of some of the stuff that we learned in the Introduction to Maya lecture, like during the info session. So first things first, you can create primitives by just clicking these buttons. Remember the hotkeys Q, W, E, and R for select, translate, rotate, and scale. If you hold right click, you can switch between the different selection modes. So you can go to face mode, edge mode, vertex mode, that type of thing. Allows you to select different parts of the mesh. If you select something or it's like select a face, you can do Control or Command E to extrude it out. And you can switch between different views with the spacebar. Here are the additional modeling tools that we're going to be covering today. First thing is the Insert Edge Loop tool as well as the Multi-Cut tool. And then we're going to be covering smooth mode. And then we're going to be talking about how to fill holes with the Fill Hole tool, the Append to Polygon tool, and the Bridge tool. Additionally, we're going to cover something such as called history, the pivots, how to freeze transformations and why they're important, grouping, and also we're going to touch a bit on normals. So I'm going to go on to the demo right now. Okay, so here we have Maya open. Just as a reminder, this is called the viewport, and this is where you're moving around on your scene. Right here, this is called the outliner. Over here is called your attribute editor. And then this is your shelf. And then the top area right here, this is your toolbar. Just keep in mind these terminologies. They might appear in lab if like tell you to, oh, look in the toolbar, then you'll know like this is the toolbar, or like, oh, look in the attribute editor, this is your attribute editor. Okay, so as a reminder to get started, just I guess to navigate the scene in case you need a refresher, if you hold Alt and left click drag, then you get to rotate around or like pivot around the screen like this. You can scroll with the zoom wheel, and if you hold Alt and middle click drag, then you can pan around like this. Great. Okay, so first things first, let's go and click one of these to say create a cube. When you first create the cube, you can go and look at the attribute editor, and there's a bunch of these tabs that happen up here. Or if you go to the channel box over here, you can see like there's different edits to you can like edit the cube here. For example, you can change the width, you can change the height, and you can change the like the amount of subdivisions here, like this. So the subdivision width, height, depth, like that. And these are how you can like sort of like edit the default primitives a bit. And then as another reminder, if you hold right click, you can go and change into face mode, and then you can use your selection hotkeys sort of like rotate and that type of thing. So you have your Q, which is your select, you have your W, which is your move, you have your E, which is rotates, and your R, which is your scale. Yeah. And then if you ever find yourself like, oh, way off here, and then you can't focus, if you just select an object and click F, then you will focus your pivot to. Okay, so with that out of the way, let's get started with creating edge loops. I'm sure you've already gotten a bit used to this when you're modeling your robots, but sort of just give you another refresher on it. If you go, make sure you're in the modeling tab right here, and if you go to mesh tools, you can click the insert edge loop button. And then you can go and click and drag on these edges like this and create an edge loop. And then if you keep dragging or keep clicking, you can create more and more edge loops. And you can see here on the left, I actually have the edge loop tool that's selected. So if I want to like select the cube, make sure I want to go back to the selection tool. So I would click Q, deselect that, and then I can go to object mode and then select it to cube around. If I want to sort of like add more geometry, then I would like create more edge loops so I can select these faces instead of like this big mega face, right? I can select these smaller faces and I can move these out and sort of deform these as I wish. Additionally, with these edge loops, you can also sort of, instead of like just moving it out like this, you can see how since these are connected, it's sort of like it doesn't sort of like make it poke out. That's where you would use the extrude tool. So if I have Control E, I can extrude. You can see this sort of like menu pops up and this gizmo pops up, and then I can go and extrude like this. And then this will sort of create new geometry. And one really important thing to mention, and it was covered in the slides as well, is that you want to make sure you don't have any non-manifold geometry. One of the things that's really easy to do that with is if I were to just extrude it, and then I don't do anything. And you can see here how it looks like I haven't extruded, but in reality, there is an additional face here. So always a good thing to practice is if you extrude something, always just move it. Never extrude and then never move something. And if you're undoing an extrusion, it sort of can be confusing if I sort of say I undo this and it goes back here and I sort of forget to undo the extrusion again, because what I did here was I undid the movement of the face. I didn't undo the extrusion. On the bottom right hand corner here, you can actually see what you undid. So if I undo again, it says undo poly extrude. I basically want to keep clicking undo until I see this undo poly extrude over here. Okay, next let's talk about smooth mode. So in Maya, there is something called smooth mode, which is very, very useful. If you click the number 3, you can see how this cube becomes a sphere, essentially. This is what smooth mode does. Essentially interpolates a smoothness between all the different edges. So for example, let's try it with some other primitives. Like let's say I have this cylinder and I click 3, it will smooth it out like this. And it looks a bit like janky simply because of all the different edges. So what essentially determines whether something is smooth or not is those edges. So for example, right now if I smooth this, it becomes a perfect sphere. However, if I go and insert an edge loop over here, like this, and then I smooth mode, you can see how it looks more like a capsule now. And the reason is because over here, I have this edge right here and this edge right here. If the edges are really close to each other, then when I go into smooth mode, it will smooth it less compared to edges that are like very not close to each other. So for example, if I wanted to make sort of like a rounded cube, what I would do is I would use the edge loop tool, and then I basically create edges like this and this sides. And you can see with this, all these edges are relatively close to this very edge here. So you can imagine that when you click the smooth mode, it will smooth just the edges, just the tiny bits, but overall it doesn't become, say, like a sphere, like when I do it with this one. So this is very, very useful when you're modeling sort of more organic shapes. Um, and you don't want those like hard edges. Turning on smooth mode can be very, very helpful to sort of get these like smooth faces out here. Yeah, so this is smooth mode. Very, very useful, and you can turn it off by just selecting the object, clicking 1. So this is hard mode, and then this is smooth mode. So hard mode, smooth mode, hard mode, smooth mode. And you switch between them by clicking 1 and 3. And basically the TLDR is that your edges define where the smoothing occurs and where it doesn't occur. So if I want like no smoothing, I basically just create an edge loop all the way to the edge like this. And then when I do smooth mode in here, it barely smooths it out compared to something like over here. Okay. I'm gonna go and delete this real quick. And then let's create another cube. Let's talk about how to fill holes. So let's go and increase the subdivisions a bit to say 10. Let's say I'm doing some modeling and I select this, I'm like extruding and I'm like doing a bunch of other stuff. Um, this, and then eventually I'm like, oh, I don't like this, right? I'm gonna delete this. Now I have a bunch of holes in my mesh, and uh, not good things are happening. Um, well, how do I fix this? How do I fix these holes? One thing you can do actually is let me get or clean mesh to demonstrate this. Okay. Let's say I have a hole here. How do I actually sort of fix this hole? One thing you can do is you can go to edge mode, you can select all the edges here, and if you go to mesh, and then you click fill hole, bam, the hole is now filled. Yay, no more non-manifold geometry. However, one of the pitfalls with the fill hole tool is that it doesn't actually create edges. It just simply fills a hole, and more often than not, it creates a lot of n-gons. So, for example, let's say I had all of these faces deleted, and I wanted to fill this hole. Um, and I would select this edge, I go to mesh, and then I click fill hole. Well, you can see it filled the hole, but all the edge loops aren't there. It's just one giant n-gon. And you can tell this is an n-gon because if you count the number of edges here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And even though the edges like right next to each other and like perfectly straight, this is still an n-gon because you have this vertice right here. And this is really bad. You don't want things like this. So you essentially want to fill a hole in such a way that it creates and keeps all the edge flows of the object. So how would you actually do that? Well, one thing you could do, especially with an object like this, is actually to fill the hole like this and then use the multi-cut tool to sort of draw edges. And the way you would do that is right here. This is the multi-cut tool. I click this, and I could basically click a vertice and then click another vertice down here, click enter, and bam, it basically just draws an edge. And you can draw like a bunch of edges with it and create a bunch of really wacky edges like that. Um, like this. You probably don't want to do this, but it's something you can do. But essentially what you would do is you would just take this, and you would just draw all the edges in like that, and bam. After we're done with this, then we no longer have this issue of a giant n-gon in the face when we try to fix the hole. Now, this is a bit annoying to do, right? Like if I have a more complex model like this, then I fill the hole. Now there's a bunch of different like lines that I have to draw. It's kind of annoying. Thankfully, there are a couple of other ways to actually fill holes as well. So let's go and delete this face again. Next, let's talk about the append to polygon tool. So if I go to mesh tools and I click append to polygon, I will enter the append to polygon tool, and it says click a boundary edge, then click a new edge. So for example, if I click this edge, every other edge becomes like pink. These means these are the edges that I can select, and if I select this edge, you can see how it created it like that. I can click G to repeat the last tool I used, and I can do this, select it like this, here, that. Um, this append to polygon tool can be good for certain simple geometries. Currently for this one, it's not really that good because it creates a bunch of these tries, and that's not really what I want regarding the geometry here. But it could be useful for other types of geometries. The tool that I would actually use the most in this situation is the bridge tool. So the bridge tool, if I select two different edges, for example, this edge, and this edge, and then I click this bridge tool right here, it creates basically a face between it. You can see here how this one doesn't actually have like the edges in the middle. If I increase the divisions here, it sort of like will create like divisions of the bridge itself. So this is very useful. And then I could repeat the last tool like this. And bam, there we go. And now you have this like fully functional hole that's filled. But wait a minute, something's not right here. And do you know why? Do you know what's actually wrong with this method of filling this hole? I'll give you hints. This is actually non-manifold geometry. And let me demonstrate to you the reason why. Let's take this face. Let's move it. It's not connected. It's actually not connected to the rest of the mesh compared to something like this, which is connected. And the reason this happens is because when I did the bridge tool, it only connected the two edges that I selected. It didn't actually connect these vertices. It created new vertices. So I essentially have overlapping vertices at this position right here. So how do I fix this? Or in fact, how do I even identify this? Well, one thing that was mentioned is in order to identify non-manifold geometry, what you could do is just click 3 and you can go into smooth mode, and whoa, you can see something is definitely wrong with this face, right? Then you can go and troubleshoot it like this, where I'm like, okay, well, something is wrong with this face. Let me try moving it. Oh, okay, well, this seems to be the issue. Well, how do I fix this? Well, there is a tool called the merge to center where you can take two vertices. If I select these two vertices and I click this merge to center tool, it will merge the two vertices into one. Now it doesn't really it sort of, when it merges it into the center. And in order to select both of them, what you could do is like you can select them both like this, and then you can click the merge tool, and then they'll merge. But sometimes that's really annoying. Like how would I actually like merge two overlapping vertices that are right on top of each other? If I select this object and do Control F to search for tools, by the way, in case you forget where they're located here. But there is a merge tool, not the merge to center, just the merge tool. And clicking this will basically, there's a distance threshold where it will merge every single vertex to the next closest vertex to it. And if I do that, then all of these faces should be fine. And if I go to smooth mode, everything is manifold. So these are some things to just keep in mind, especially when you're modeling. There are a lot of different methods on how to achieve something. You can use the fill hole tool, a pen to polygon, bridge tool, and they each have their own unique strengths and weaknesses. However, knowing how to sort of like debug these issues that would occur, switching into smooth mode, trying to identify certain faces that aren't working, checking whether your geometry is manifold or not, is very, very important. If you have any questions with it, if you have any meshes that are kind of like wonky, feel free to just let us know in the Discord, and we could definitely help you out with it. Okay, so with these basically these modeling things out of the way, let's talk a bit about Maya's history system. So essentially, the way it works is that every single action or application that you do to a mesh is stored in something called the mesh's history. Um, and this history includes everything from moving vertices to extruding to beveling to all this append to polygon stuff that I've done. And actually, if you look in the channel editor here, you can see everything that I did to this cube, right? I have this polycube, and then this, I split it, and then I append polygon, and then I bridge tool, and then I merge vertices and stuff. All of this is stored in the history tab. And this could be very useful for certain things that I want to like edit in the future. So if I can go and like change these like values I did and like the settings. However, history ends up also causing a lot of problems. Because if your history gets way too long, then you have a bunch of basically these what's it called? You have a bunch of these different transformations that are applied in the history that's saved in memory, and it causes mine to slow down a lot. Additionally, a lot of times having the history within an object still can cause a lot of issues. So for example, if I try to go and change like the subdivision width of this cube, yeah, bad things happen. You don't want to do that. And the reason is because this happened at the very beginning and it did all of this stuff on top and it doesn't really know how to sort of interpolate between all of this stuff with all this these changes in these values. What you want to do, and this is very, very important, every time you're sort of like happy with your mesh, or just every now and then in which you don't need the history or you don't need to sort of like go back and like change something, just click this button right here, the delete history button. If you click this, bam, all the history is gone and all the changes that I did get applied to the mesh. So for example, if I have this face and I extrude it out like this would get stored in the history down here in this poly extrude face. You can also see this in the attribute editor with all these tabs. And essentially, if I keep extruding and then I keep extruding like this, these extrude faces basically like end up populating this attribute editor a lot and becomes really, really busy. So just every now and then, just click the delete history button. I cannot stress how important this is, especially because when you get to really, really complex models and you have a massive, massive history, it can be really difficult to navigate things. And if something breaks with your mesh and the history isn't deleted, it can cause a lot more issues as demonstrated earlier. So just every now and then, click the delete history button. Yeah. Okay. Next, let's talk about the pivots. So when I created this cube here, I have this pivot or this gizmo. And this gizmo here is like the center of location, or like it's the center of all the transformations. It's where this thing is located. And sometimes that may not necessarily be too useful to have it like in that location, or maybe it's in a really, really awkward location. Like what if let me take this and I like extrude this out like here like this, and have this weird cube with some arms, and I want to control this from the center, like not where the cube is located, but like where the middle is located, especially when I want to rotate this object. How would I do that? Well, this button right here is the center pivot button, and it basically centers the pivot to the middle of the mesh. So now the pivot is where the average of all the vertices are. And that's how I can center the pivot, especially if I'm working on something and it gets really big in like one direction and the pivot is all the way in the other direction. Well, clicking the center pivot button will center the pivot. Additionally, you can also move the pivot manually. So if I click the D button, we'll enter this mode, and I can move the pivot all the way over here. And if I go back to like my QWER, now the pivot is in this location. So you can move the pivots around if you want, like this over here, like that. If I ever want to center the pivot again, then I just click the center pivot button. Okay, now you notice that we covered two of these buttons. What is this third one? Freeze transformations. So in Maya, every single object has a transform attached to it. Delete the history real quick. If you look over here in the attribute editor, this p cube 1, this is the transform, and it basically defines all of the elements of like the location of this mesh. So if I move it up, you can see how the y axis of the translate moves. Or like if I move over here or I rotate it, you can see how all these numbers move. These numbers define the transform position of the object. And essentially, if I reset these back to 0, like this, then it gets centered again, like this. And the reason why it's not like in the like actual center is because I moved the pivots. But essentially, this is what the transform is. Every single like rotation, movement, scaling, changes to transform. And this is what is actually happening when you apply these tools. Well, sometimes I want to go and apply this transformation. Let's say this is like a spaceship, and I like the current location in which it is located, and I want this new position to be 0, 0, 0. So then what I would do is I would click this freeze transformations button, and everything gets applied and everything becomes 0, 0, 0. And you can see here how if I move it and then I turn it back to 0, it goes back to this position. This is very, very useful for, say, like things like props. So let's say I have this cylinder and this plane here. Like this plane is the ground floor, and the cylinder is like, I don't know, like a pillar, right? And I want to make like a sort of a building or like a house. And I move it all like this. Like these define some sort of like house. Then what I would want to do is I want these locations to always be here relative to each other. Um, for example, like if I'm like moving these around, like maybe the house is like tumbling down and I'm like editing it. Well, like, oh, now I moved it and now I don't know where the original position was. And if I try to zero out all these transforms, well, this is where the 0, 0 is, and it doesn't go back to where I wanted it originally. So what I would do is I would move it to where I want it, and then I click freeze transformations, and then this will be 0. So if anyone ever moves it accidentally, or if I'm moving it for animation purposes, then in order to reset it, I could just set everything back to 0 like this, and then it'll go back to the original position in which I was defined. So one good thing and good sort of like good like practice to have is that every time I basically finish my model, just click the freeze transformations button, and then this will freeze your transforms so that if any sort of changes happen to it, you can always go back to its original location. Okay, great. Now with freeze transformations out of the way, let's talk about how we can actually take all of these different objects and sort of move them together as one. Like I mentioned earlier, this is like some sort of like pillar or some house or something. And these are all sort of like supposed to be like one object. I don't want these to be be able to move separately. I want them to be moved together. If one like, oh, I don't like the position of this, now I have to move everything manually one by one. And that's kind of really, really annoying. The first thing what I would do is I would select this and go to the outliner. And you could double click to rename this. So they call this roof. And then maybe I'll call this like pillar left. And then pillar middle, pillar right. And it's really good practice to actually name all of your objects. Essentially, because if you don't, then you're just gonna have like cube 1, cube 2, cube 3, cube 4. And it's like, I don't know what cube 15 is. And that can get pretty frustrating pretty quickly. So make sure just to name all your objects. So what I can do is if I select all of these objects and I click Control G, I can group them. And it groups them together like this. And I can call this house. And this group, if I select this group, selects all the children underneath the group, and then I can move them together as one like that. Or I can also center their pivots. I can also freeze their transformations, delete the history, all of that good stuff here. And if you can see, there's actually this empty transform object that is parented to all of these children here. And that's what the group does. It basically creates an empty transform, which is a nothing object, and then it parents it. Alternatively, you can also parent things yourself. If, say, I have this house and this floor, and I want to parent the house to the floor, I would middle click drag into the floor. You can see how the house now is a child of the floor. So if I select the floor, it selects the house, and I can move things separately like that. Very useful for organization purposes. It's good to have a good organized outliner for things that could be related. And it's very useful to just have a empty group to do it, things like that. Okay. Yeah, that's essentially all there is to cover. Um, and let's talk one last thing about normals. You might come across these shading issues when you're modeling, so it's good to talk about them. Essentially, the idea of a normal is that every single face has a front side and a back side. So, for example, you can see this face here is all, like this cube. When I deleted this face, everything inside is black. And the reason is this is actually the inside of the cube. Every object, every mesh is a 0 thickness face, and then the face has a front side, which is colored, and a back side, which is completely black. And you don't want things like this. This is really bad. You never want to basically see the inside of a mesh. It can cause a lot of issues because there is no thickness here. These faces have no thickness. One way you could resolve this is you just take all these edges, these faces, and then you could extrude. And then if you change the local offset Z, you can extrude them like this, extrude them all outwards, and now there's thickness again. But notice how if I try to extrude inwards, everything is black. And the reason is because this is actually the wrong side of the face. If I were to say like go inside this, um if I were to say go inside the object with my camera, you can see how the inside of the object is actually colored. Basically, all the faces are inside out. How do I fix this? Well, if I go to mesh display and I click reverse, this will basically flip all of the faces. So every single face will get flipped to its other side, and then you basically you have the normal pointing in the right direction. So the normal is the direction that the face is facing. And if one of them is facing, say, the wrong direction, then it can appear black while everything appears correctly, and then just one face is black. So if you ever have a black face, chances are it's probably a normals issue, in which you could just select the face or select the entire object, and mesh display reverse, and then bam, you fix the issue. Yep. Okay. Yeah. If you have any questions about anything you particularly want to do or anything about what was covered, I know this is sort of like a recording and you can't really, I guess, talk to me real time, but just leave a message in the Discord and we'll be sure to respond to it. Yep. Okay. So one last thing I actually forgot to mention is the idea of floating vertices. So for example, let's say I have the insert edge loop tool and I'm inserting the edge loops like this. And I realized, okay, I actually don't like this edge right here, and I want to delete it. Well, I can double click to select the entire loop like this, and then if I click the delete button or the backspace button, oh wow, it deletes the edge, and then all my problems are fixed. Wrong. All your problems are not fixed because if you go to vertex mode, you can see that deleting the edge only deleted the edges. The vertices that make up the edge still exist, and now you have a bunch of n-gons, and that causes a lot of problems. So how do I fix this? How do I solve this? Well, instead of deleting this using the backspace key, what you want to do is select the edge and hold Control and then click backspace. And if you do that, you will no longer have any floating vertices. If you come across like a singular floating vertice, you can always just go to vertex mode, select, and like delete them manually. But to sort of avoid having this problem to begin with, every time you delete an edge, just select the edge, Control Delete, get rid of all the vertices that make up the edge. Well, very, very, very important. Additionally, with all of these edges and the edge loops, you may notice that sometimes your insert edge loop tool doesn't work. And the reason that could happen is if you have like a try. For example, if I do this and I create this triangle, and then I were to say insert edge loop tool, it doesn't connect. It doesn't fully connect, and the reason is because you cannot make a loop around this. This is the insert edge loop tool, and if it's not possible to sort of like create a loop because there's like triangle or some like non-manifold geometry, then it won't be able to create the full loop. And this is how you can actually diagnose some of like the manifold geometry type of issues that can occur. Yeah. So if I want to delete this edge, Control Delete, make sure I delete all of the floating vertices that accompany it. Yep, that is all. One last thing. How do I duplicate objects? So normally you would think like Control C, Control V, and then I duplicate the object. Don't do that. You notice here how when I duplicate the object with Control C, Control V, it created this new group, and then it pasted the cube like that. Control C, Control V is nice for very, very niche situations in which you want to keep the entire history of the object and everything. But more often than not, if you just Control C, Control V, like this, you end up creating a lot of different problems in your outliner, and now you have these groups that are like nested with each other and everything, and it gets very, very disgusting very, very quickly. So I would highly recommend to never use Control C, Control V. If you want to duplicate an object, instead use the duplicate tool, which is Control D, E for duplicate. And if I do that, then it simply will duplicate the mesh. And you can see it only duplicates the mesh. It doesn't create any weird groups or anything. So if you want to duplicate an object, just use Control D. Never use Control C, Control V, essentially. Yeah. Back to these slides. Here are some good practices to have, essentially TLDR. Move faces after you extrude them. Otherwise, you wouldn't know that you extruded the face and they're overlapping with each other and cause lots and lots of issues, especially when using smooth mode. Use Control Z twice to get rid of the extrusion. Check the script editor, which is the tiny bottom right hand corner thing that tells you what your previous action was. Um, Check your model for holes. You can use the mesh cleanup tool to sort of like clean up any sort of non-manifold geometry, though I would recommend doing this manually as this can cause some issues sometimes, and it's also just good practice to know how to fix non-manifold geometry. Use Control Delete over regular delete as much as possible, so you don't have edges that have floating vertices. And then make sure to delete history. Keep your outliner clean and organized. Don't have cube 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like cube 200. That's bad. Name your objects. And focus on maintaining good edge flow. Here's some bad practices. So double extrusions, floating vertices, n-gons, any holes that are in mesh. You can notice these better in smooth mode. Try to fill all your holes. Yeah. Here's some troubleshooting tips. So you can use the appended polygon tool or the bridge tool to sort of like fix any holes that might happen. You can like double click your edges to check the edge flow, make sure they're looping. And you can check in smooth mode to see all these double extrusions and the type of thing. And if you have any extra vertices, you can always merge them. And remember, this is for group work. To set your projects. This, I believe Rebecca covered this last lecture, but setting your project basically makes all your file paths relative, which means that other people can access the files that you can also access, right? You don't want to have something linked like an asset or like an image to your homework folder because other people might not have a homework folder on their desktop. So make sure to have everything within your project file and then set your project every time you create a new scene or new assets. Set your project to the project that you're working on, so all your other group members can have access to all the files that you have, and you won't have issues like, "Oh, the file doesn't exist on my computer." Yeah, set your project, please. Actually set your project. This is very, very, very important. There are a lot of issues that can happen if you don't set your project, or if certain files are set to the wrong project and that type of thing. I will say though, try not to have your homework in this. Like don't put your toilet modeling lab in the group project file. I mean, unless you want everyone to see your homework submissions, in which, by all means. But yeah, make sure to set your project. Okay, so this is your homework for today. Your individual homework is to complete the basic modeling toilet lab, in which you'll be modeling a toilet. Make sure to check the website. The website has a lab that's a link to the toilet lab, and you basically just follow the instructions there and you submit on B courses. For the group assignments, make sure to model all your props. So look at your asset list, look at all the props that you need to model, and start like distributing them and like modeling them. You should have essentially all the knowledge that you need to do to model your props now. If there's anything complicated that you want to learn how to model, just send us a message on Discord. We'll be happy to help. Additionally, for your group assignment, there's additional assignment you have to do, which is a weekly team progress report. That will get showcased next week. And it's just another B courses assignment. So yeah, attendance, or I guess come to office hours, yay. Yeah. Attendance, you don't have to do this because there is technically no class today. But if you want to fill it out, the keyword is manifold. There's some really important like feedback stuff here, sort of like what we can improve on and things like that. So I highly recommend you to fill this out. But again, you don't have to because you technically don't have class today. But yeah, that's it. So thank you all for watching until the very end. I hope you have a wonderful week, and I hope all your shorts turn out amazing. Bye bye.